So genetic algorithms, we talked about this a lot. In fact, I think we beat this so much that everybody gets it. Any questions on genetic algorithms? You should know about crossover and what it is and how to do it. If I throw up a genome and say do crossover, you should be able to draw a line and take half from one gene and half from the other gene. If I say, what's the point of mutation? Is it to promote diversity or to select the most fit member of the population for survival? You better know which of those it is. It's diversity, by the way. And if I said, how does a tournament work? You should know that there's lots of ways to do tournaments. What's a fitness function? As long as somewhere in your algorithm you're killing the less fit members of the population, you're good. And how can you do that if you don't know who the less fit members of the population are? Well, maybe it just happens because the less fit members don't know how to survive. That's kind of how we think nature does it. But when you implement it, you need some kind of fitness function. Let's do a utility theory question or two, just because I know we covered this, but it involves math, and math is hard for people. So do you agree? You want me to do a utility theory practice question? Okay, thank you for interacting with me. Makes me feel better. All right, so what should the question be? Not the lottery. Okay. How about, I don't know. Something about pay for. Okay, you open a new pizza restaurant. It's AI Paisanos. I'm feeling hungry. You have a pizza restaurant, and then a member of the mafia shows up and says, nice pizza establishment you got here. It'd be a shame if it were to burn down to the ground on Tuesday at 2 p.m. Would you like to pay some money to the mafia boss? Now you have a choice. You can pay or not pay. And you say, what's the first question you ask?
What are the chances?
How much does he want? And the mafia boss says, what? For you, we make a special deal. Today, for just 500 big ones, you can be sure that your pizza establishment won't burn down on Tuesday at 2 p.m. And then you ask him, what is the probability that this mob boss will follow through if I don't pay $500? Let's see, probability of no pay is, and he says, if you don't pay, the probability of burning down is 75, and the probability if you do pay is there's still a 10% chance that we'll burn down your establishment. And you say, thank you very much for the information.
What about the last 18? Yeah. It doesn't matter. Good old.
Wait. Should these numbers add up to 1? They're both saying the probability that you'll burn down. The probability that you won't burn down is 1 minus these things. And there's two possibilities, right? If you don't pay, there's a 25% chance that you'll be fine. And if you pay, there's a 90% chance that you'll be fine. Okay? What other information do we need to solve this problem? Yeah, what's your pizza joint worth to you? Or what would it cost to replace? Or what's the, you need some information on that. Let's suppose that each pizza costs $15 per pizza. And your pizza joint costs, I don't know, $10,000. That's a really cheap building.
Yeah.
At the 30s?
$15 pizza, 19.
Okay, it was a $2 pizza.
All right.
Plus $1 per topping.
Whoa.
10 cents per topping.
Okay, yeah, there we go.
A dime. You got a lousy dime, you can have a topping. Okay, $10 to rebuild establishment. And let's suppose that your establishment is worth exactly $10,000 to you. What other information do we need? How's your insurance? Do you have insurance? We could complicate it. Sure, okay, let's say you have 3 options. You could pay the mafia, you could not pay the mafia, or you could not pay the mafia and go tell the cops and buy insurance. Yeah, so now we could work into cost of time, how much time would be lost if it would take you, say, 2 months to rebuild, and how much business would be lost in that meantime. Okay, we could make this very real world, and then it'll take all of class period to answer it. So I'm going to say it costs you precisely $10,000 if your place burns down And that has factored in all possible considerations. We good with that? Just to save time. And by the way, on the test, I'm not going to make it as complicated as I possibly can. I am going to make it sufficiently complicated that you have to know how to do it, right? Okay, so, but yeah, in the real world, it's never going to be this simple. You're always going to have to be considering how much time is it going to take, how many pizzas would be lost during that time, how much sympathy would I win from the public? Hey, what's the value of that sympathy? Would that actually result in more business? Maybe I should burn it down myself. And you know, there's a whole lot of things. Plus, you'd also have to consider in paying, you're actually destroying the United States of America, right? I mean, you have to consider there's ethical ramifications, and that has value, and it should have value. And if you're not considering that value, you're being immoral, or amoral at least, and that's not okay. But for this question, we live in a universe where you care nothing about morality, you only care about money, which is not good. We live in that? No, we don't. Okay, well, whatever. For this problem, those numbers represent reality, and if they do. Okay, can you be moral and still use utility theory? Yeah. Absolutely. You just have to start putting values in for the things that you have value to. And I'm not doing that here because for right now, this represents reality. Okay, what goes at the top? We're going to build a tree. I think it's going to be a decision. Because, see, you have to make your decision first, and then the mafia decides whether to burn you down, right? You could put the probability that you'll burn down at the top, but they don't burn you down and then you say, okay, I'll pay, right? If that were an option, do that one, because they show up with their torches, then you pay, they walk away. That's the option, because then there's a 25% chance you won't even have to pay, right? So I think your decision comes first, and so first you have to pay, go suck on a lemon, or I'm calling the cops. Actually, I don't think you should tell them. I think you should just call the cops. But if you call the cops, let's say there's a 90% chance that they will kill your family, and a 10% chance that the cops will get them first, and they'll all go to, oh, and your family is worth $100,000 to you. Mobsters go to jail, and that's worth $20 to you. Okay, so here there's a probability. Okay, what do we got? So here's $100,000 to you because you've helped America by sending the mobsters to jail. Not because, yeah, I mean, oh wait, no, that was your value of your family. This is your value of sending the mobsters to jail. That should definitely be negative. Thank you. These are the kinds of details I want you to be able to work out. Well, this is all funny. Let's get down and start doing some numbers, right? Okay, you can pay or not pay. If you pay, there's a 75% chance it burns down. Okay, let's say it burns down. What's the utility of that? Negative 10K, right? All right, let's put it down next to pay. How much do you have to pay? Minus $500 if you pay. Okay, if it burns down, there's a 0.75 chance. There's a 0.1? Okay. Sorry, I'm moving too quickly here. 0.9, okay. If it doesn't burn down, what's that worth to you? That's a good zero, isn't it? Because you don't care? Okay. If you don't pay, two things could happen. Now, there's a 75% chance that on Tuesday at 2 p.m. they'll burn down your establishment. So this is going to be a minus 10K. And the don't pay, that's another zero, isn't it? Okay. And do we have probabilities on the cops? Yeah. This was a 0.9. Did they kill your family? This is not a lot of faith in the cops. Apparently this is a pretty corrupt time. And all right. Well, what's the right decision? It's the one that has the best utility, right? The only way we can know that is if we know the utility. So if we're going to answer this question of which way should you go, this way, or that way, we need to know what is the utility of paying, no paying, and secretly calling the cops. Let's answer the question. What's the utility of paying? Well, right here we have a probability. How do you deal with a probability in utility theory? You marginalize away the probability. Probability times the value. It sums up to 1, therefore, or integrate away the probability. What have we got? 1 times minus 10,000 plus 0 times 0.9.
Subtract 500.
And then we have to subtract 500. Now, a lot of times people get confused, and in fact, I got confused on this in my book, and there was a bug, and some people pointed it out. Thank you, those of you who found it. They'll stick that minus 500 in just one of these cases. Do you see why that's wrong? Because you have to pay whether or not the mafia burns you down. You don't get to say, oh, you burned me down. Well, here's your $500. Or you didn't burn down, here's your $500. Okay, so you have to answer what the question is. And in this case, the question is, you pay no matter what. In fact, I'm going to put it first because you pay first. And then the odds happen. Make sure your math represents reality. Otherwise, your answer will be wrong. Right? Okay. That's why I put the 500 up here, is because it's kind of done outside of the probabilities. But it's not where you put it on the tree. It's did you know how to turn it into a right mathematical equation is what really matters. And the utility of that is minus 500 plus 0.1 times negative 10,000 negative 1,500. The utility of paying is negative 1,500. Is that good or bad? That's bad. You live in a sucky world where on average you're going to not do worse than 0. Hopefully your pizzas are bringing in more than that. And, should we consider how much you're making in pizzas? Incidentally, it doesn't change the outcome because, well, it would if the pizzas weren't folded into this one. But if you're making the pizzas in all cases, so suppose you add 10,000 to all 3 branches, what's going to happen? You're still going to make the same decision, right? Yeah, I shouldn't have picked that number. I'm saying, what if you win the lottery no matter what? Does that change the decision you should make?
No.
No, because then it's $1 million plus these things, but still the biggest utility is still the biggest utility. So you don't have to factor in the price of tea in China just because it doesn't affect the outcome, even though it does affect the utility. Okay, yeah, here's the value of no paying. 0.75 times minus 10,000. Negative 7,500. Negative 7,500. Okay. Yeah, how bad is it to call the cops? 0.1 times 20 plus 0.9 times minus 100,000. How do we make a decision now? Choose the least crappy world. Yoink, it's pay the mafia. I am not endorsing paying the mafia. I do not think this is the right answer. I do not think these values represent reality, and etc. There are all kinds of problems with this. And one thing you can do with utility theory is think about what decision you would make and then adjust the numbers until they match your decisions, and then you've figured out the values of things. And that's another thing we can do. And I very well might ask you a question like, okay, let's suppose that you're actually now the mafia has recruited you to be you're good with numbers, you're our new financial person. How much should we charge people to not burn down their establishments? You want to make sure they're still choosing to pay, but it needs to hurt as much as possible until, we want to maximize our profits. What number can you charge until this utility is equal to the lesser of these two utilities?
60.
Okay. Cool that you did it in your head, but for everybody else's sake, how did he get that number? Let's call this x. And we'll say 0.1 times x plus 0.9 times 0 minus 500 is equal to, or no. What? 0.1 times minus 10k plus 0.9 times 0 minus x, or plus x, depending on whether it's negative or positive on how you represent it. And by the way, do get your minuses straight. Pay attention to those. Those make all kinds of errors in these questions. Is equal to, and we already know the utility of the lesser of the other two branches, right? Minus 7,500. Solve for x. I'm going to assume you guys know how to do basic algebra. I think that's a fair assumption given the prerequisites for this class. So you can solve that. The real question I'm asking is, can you produce the equation? Can you build these trees? There is a whole chapter in my book about how to do this. I've done one example for you here, but it really wouldn't hurt you to just read through that and make sure you get it. And if you do, you're totally ready for the test. I think I'm good. Any questions on utility theory? Okay. And the real thing to check yourself on is, given a worded question, given a story problem, can you turn that story problem into a tree that represents right reality? I know you guys can collapse those trees. It's not hard. But you should know how to get from words to an actual decision, because we need to know how to make decisions in this class.